This will be section 9.8, factoring completely. We will be looking at 4 different things. Number 1, factoring out a common binomial. Remember, that has 2 terms. Factor by grouping, which we technically have done in this section where the coefficient of x squared was not 1. Factoring completely, which is really understood when you say factor, that a polynomial should be factored completely, and then solving a polynomial equation. So let's look at the first thing where we are factoring out a common binomial. Let's take this problem. If you notice, remember, a binomial is 2 terms, and we're factoring out things that are multiplied together. This is a common binomial, meaning it's the same thing. This is multiplied by x. This one is multiplied by 1. There is a 1 there, understood to be there. So remember, when you factor out the x minus 2, it's gone now, and you're left with x plus 1. And that's the way that one would factor. A second example. Let's take x times x plus 5 minus 3 times x plus 5. You notice a common means the same thing, binomial. We factor out the x plus 5. We're left with x minus 3. This goes out, x plus 5, x minus 3 is left. Now let's actually set up where we have to factor by grouping the second problem that was there. Let's take a cubed. Let me change this to x's because a's sometimes look like 9s. X cubed plus 3x squared plus x plus 3. So let's group things together that would have a common factor. Now, you may not recognize that there's a common factor here. You may want to switch and put those 2 together. Or if you do group these 2 and you see that an x squared would factor out and you realize you would be left with x plus 3, which is what this is. Let me rewrite this one. Let's move these 2 terms. Community property allows me to switch the order. Now, let's group them like this. The first 2 and the last 2. This set has a common factor of x squared. We take out 2 of the x's, we have 1 left. We take out the x squared, we have 3 left. Now, you notice that this is an x plus 3. If I group it together, there's a 1 out here. There's 1 set of x plus 3s. Now, the common factor, binomial factor, would be x plus 3. If you take that out, you're left with x squared plus 1. And you always double check these to see that they cannot be factored anymore. If this were an x squared minus 1, hopefully you'll recognize that's the difference of squares, and then you would factor that on down. Now I moved these terms over. Now let's group the first 2 and the last 2, and let's see what happens. These have a common factor of x. If I factor that out, I'm left with x squared. Remember, you remultiply that, you get x cubed plus 1. So x cubed plus x. This has a common factor of 3. If I take out the 3, I'm left with x squared plus 1. So that when I redistribute, I have 3x squared plus 3. Now you notice my common factor is the x squared plus 1. If I take that out, I'm left with x plus 3. So in many cases, you can group these together in more than one way. Let's find another example with the grouping. Let's take y squared plus 2x plus yx plus 2y. Now, if we notice, if we were to pair these two together, there's not a common factor there. And there's not a y squared over here. I am going to move these two terms, y squared, switch these two, plus yx plus 2x plus 2y. See, if I had grouped those, there's no common factor there. And when I group those, the y would be x plus 2, and that's not what's there. So let's let's group these, because I can quickly see that they both have a y, they both have a 2. So let's take out the y. We're left with a y plus the x. We took the y out, so that's y squared plus yx. Let's take out the 2. We take that out, we're left with x plus y, which is the same as y plus x with the commutative property. So the common factor, we can write it either way. We typically write it alphabetically, so we'll write x plus y, and what's left is y plus 2. And there's your answer. And please note, if you look at your answers, you look them up in the back of the book and you see y plus x, understand that that is the same. Now let's look at some problems where we are factoring completely, meaning to get everything out that is shared. Let's take 4x cubed minus 44x squared plus 96x. Now, real big here. Always, before you start, and I forget this sometimes too, so it's always a clue to look for a GCF before you try to start factoring this. Because you would multiply 4 and 96, try to find all the factors, and that would take a while. So it appears that these obviously both have a 4. And if you quickly look at that, it is divisible by 4. They also all have an x. So we can factor out first a GCF of 4x. Out of here, I take the 4, take an x, I'm left with x squared. Divide out 4, that's 11. I took out 1x, so I have x. Plus, I'm taking out a 4, you divide that out, that should be 24, and I took the x out. So that's what's left. Now, don't drop what you have factored out. This is a trinomial that we hope will factor. This is what I call trial and error method. I'm going to look for factors of 24 that have a sum of negative 11. Now, I already know that this is going to be an x minus and an x minus because this is a plus and I have negative in the middle. So when you multiply the last in your FOIL, negative times negative would be positive. So what are factors of 24 that would give you 11? Well, you can pair them up if you're not sure, but hopefully, whoops, that's a 12. And hopefully you already saw, by the way, these would be negative, because we want the two negative ones that would equal 24. And hopefully you already saw that it should be those two right there. So an x minus 3 and an x minus 8. And that's the way that would factor. Let's look at 50h to the 4th minus 2h squared. Now remember, GCF first, if there is one. These are both divisible by 2. They both have 2 h's. So I'm going to factor that out. I'll get 25h squared minus 1. Now let's look at that. That gives me 50h to the 4th minus 2h squared. I hope that you recognize this is a perfect square, this is a perfect square. This is difference of squares. So it factors, remember the square root is 5h, the square root is 1. So it factors into 5h minus 1, 5h plus 1. And that is the way that that problem would factor completely. Again, it doesn't matter if you have the 5h plus 1 first and then the 5h minus 1. They're two things multiplied together, and that also follows the commutative property. These problems want you to pause the video and work it out. 3x cubed minus 12x. So pause the video, try the problem, and then continue. I see a GCF. Both of those are multiples of 3, and they both have an x. If I take out 3x, I have left x squared, check that, 3x cubed minus 4, 12x. This is difference of squares. So we have 3x, this factors x plus 2, and x minus 2. That is your answer factored completely. Let's take 2y cubed minus 12y squared plus 18y. Again, pause the video and work the problem yourself and see if you get the answer that we're going to get here. Does have a GCF. They all have a 2, the multiples of 2, the numbers. They all have a y. So let's take that out first. We took out the 2, we took out a y. Divide out of 2, we have 6y plus 9. We took out the y. Now always multiply this by distributive to make sure that what you have here is correct. That's 2y cubed minus 12y squared plus 18y, so I'm okay. And hopefully you'll get used to recognizing this is a perfect square of y, this is a perfect square of 3, and this is twice the product. So this is the square of a binomial. Just abbreviate that. Don't forget the 2y. If you leave that off in a final answer, I have to take points off your grade because it is part of the answer. This is y minus 3 squared. You can write it y minus 3 times y minus 3. That's what y minus 3 squared means. So either one would be acceptable. Again, pause the video. M cubed minus 2m squared minus 8m, and work that problem, and then see if you get the answer that we will get on the paper. They do have a GCF. They don't have a common number, but they all have an m. We take out the m, we're left with m squared minus 2m minus 4. And let's check that. M cubed minus 2m squared minus, oops, that was an 8. That's why you check it. Now let's check again. M cubed minus 2m squared minus 8. There was an 8 there. Now, this factors. Don't forget your m. This should break into two binomials. We need factors of negative 8. That would give me a sum of negative 2 in the middle. And remember, this is going to be 1 and negative 8 or negative 1 and 8. This is going to be 2 and negative 4 or negative 2 and positive 4. That should be all the factors. Now, which one has a sum of negative 2? It would be this one. So we would have m plus 2, m minus 4. And again, it doesn't matter which one you write first. Check this always by FOIL as I'm getting some of the papers turned in. Many of you are not checking by FOIL. You're giving me a wrong answer. So let's check this. M squared, I'll write it right here, m squared minus 4m plus 2m minus 8. And that does give me minus 2m minus 8. And then, of course, that would be multiplied by m to get the original problem, m cubed minus 2m squared minus 8m, so we get back to the original problem, and we are correct. Now, let's look at solving a polynomial by factoring. So let's take this first example, 3x cubed plus 18x squared equals negative 24x. First thing, always, needs to be set equal to 0. So let's add the 24x to both sides. 3x cubed plus 18x squared. We're going to add 24x equals 0. Move this to the other side. Those of you who want to show that across there. Now, I do see, and hopefully you recognize, there is a GCF, 3 and an x. So what's going to be left? X squared, when I take the 3 and an x out, 6x and 8 equals 0. Do not forget the equals 0 part. Now, I need to factor the remaining trinomial. Don't lose the 3 times x, because that's going to be one of the answers right there. Equals 0. Do not leave off the equals 0. These are all the steps that should be shown on your paper. So we are factoring this. Should be an x plus and an x plus, because the last number is plus and the middle one is plus. I need a sum, just to remind you, that's 6. 1 and 8, 2 and 4. So it's x plus 2, x plus 4 equals 0. Now, you have this factor. Remember, the zero product property says if things are multiplied together to give you 0, something has to be 0. Well, 3 can't be 0, but x can be 0. That's one answer. X plus 2 can be 0. X plus 4 can be 0. So we subtract 2. We get x equals negative 2. We subtract 4. And we get x equals negative 4. So our answers are 0, negative 2, and negative 4. Just a reminder again, a degree 3 equation will have 3 answers. Sometimes there's a double root, so it would appear that there may only be 2 answers. So we have 0, negative 2, and negative 4. You cannot drop any of this in your answer, and at each step it should be set equal to 0. So let's have you try another problem. W cubed minus 8w squared plus 16w equals 0. Pause the video, see if you go ahead and try it on your own. There is a GCF. That's the first thing you look for. Well, first thing is it's set equal to 0, so we're ready to go. Factor out a w. W squared minus 8w plus 16 equals 0. Don't forget that. Let's check it. W cubed minus 8w squared plus 16w. Don't lose the w. The trinomial should then factor into 2 binomials. It does appear, if you're looking, that this is a square. W is a square root, 4 is a square root, and that's twice the product. It would be w minus 4 times w minus 4 equals 0. Or you can just factor it as a polynomial. You don't have to write w minus 4 squared. Now, each factor can be 0. So this can be 0, or this can be 0. That is the same thing. We add 4. And we get W equals 4. There are our two answers. There's a double root of 4, so that's why you would have 3, but it appears as only 2. And you don't have to solve that twice. Let's take one more, if you will write it, and then pause, and you work it. 7c squared plus 12c equals 0. It is set equal to 0. I see a GCF of c. Every term has a c. So if I take that out, I'm c squared minus 7c plus 12 equals 0. Let me check it, make sure I did it correctly. C cubed minus 7c squared plus 12c. Now, factor. That's not a perfect square, but I know it's a minus and a minus because the last one is positive. And the only way I can get a positive is to multiply two positives or two negatives, but I need the sum to be negative 7. And you may quickly, hopefully you see that it is 3 and 4, but my possibilities would be 1 and 12, negative 1, negative 12, 2 and 6, both negative, 3 and 4, and there's the 1, of course it's negative 3 and negative 4. So this is the way it factors. Again, each factor could be 0. This can be 0. This could be 0. The last one could be 0. So if you add 3, you get c equals 3. You add 4, you get c equals 4. So we'll put it in a straight line here, or c equals 3. Some people will just write c equals 0, 3, or 4, like that. One more problem. Let's see, x cubed minus 25x equals 0. Pause the video, see if you can work it. And these obviously teach you or to use pretty much all of the factoring we have done in this chapter. Set equal to 0, I see a GCF of x, so I'm left with x squared minus 25 equals 0. Recognize both of those are perfect squares. Again, don't lose the x. This factors into x plus 5 and x minus 5 equals 0. Remember, you need to write that each time. You can't solve something if it's not set equal to something. Either of these can be 0. X can be 0. X plus 5 can be 0. X minus 5 can be 0. So if we subtract 5, we get x equals negative 5. We add 5, we get x equals 5. Here are the answers. Sometimes we'll write x equals 0, comma, plus or minus 5. Or you could just write it x equals 0, 5, and negative 5. But sometimes you may see it written like that. A plus or minus 5 means it could be a positive 5 or a negative 5.